But the mathematics that goes into such a simple thing is surprisingly complex. There are partial differential equations that need to be solved, contouring problems that need to be solved, lots of advanced calculus and advanced mathematics that go into a part like that.
Well, as part of our theme on big data and AI, I'm delighted now to be joined by Dr. Thomas Grandine from the Boeing company, who's looking at solving mathematical problems from a 21st century point of view in his session here at ISIUM 2019. Thomas, thank you so much for joining us.
Thank you for having me.
Could you tell us first, in what way is Boeing undergoing a digital revolution?
Boeing is rethinking the way everything in the company is being computed, from the earliest stages of design all the way through manufacturing and eventual support of our products. And the common, the theme that gets used to describe that is digital thread, that we are attempting to tie every calculation and every bit of computing that we do together from the very beginning of the design phase, earliest design phases, all the way through to product support.
And what role does the Python programming language have to play in that?
Python is very good at enabling different capabilities to script together with one another, and so Python is going to be one of the bits of glue that tie all the different computing capabilities together.
So what's the connection between the model that you're depicting in your session and the mathematics behind that model?
It's a very simple model, and the thing that I like about it is that there's a lot of very interesting advanced mathematics that goes into it. For one thing, this is a surface that is a developable surface, which means it can be flattened without introducing any distortion or error, unlike a globe, for example. And when a surface has that property, it can be easily manufactured by folding. In this case, we do a lot of work with advanced composites, which have to be put on a surface like this. The other thing that's going on is that the location of this stiffener down the middle is determined in a very mathematically precise way so as to make this part just as stiff as possible. But the mathematics that goes into such a simple thing is surprisingly complex. There are partial differential equations that need to be solved, contouring problems that need to be solved, lots of advanced calculus and advanced mathematics that go into a part like that.
And what's this part used for?
This part is not used for anything except as a demonstration of the mathematics. So we would use this part at Boeing for training. The idea would be to demonstrate to the engineers how the mathematics pertains to the actual design of airplane wings that they have to carry out, which is a much more complex thing, but the underlying mathematical principles are all the same.
I wonder if we could just talk a little bit about Boeing as well, because it's obviously been a challenging time recently for Boeing. And I know that you're not an expert at all on onboard systems or flight control software, but what is the engineering and safety culture at Boeing, and how does that impact your product development?
Right. So Boeing always puts safety first and always has. And the thing that has continued to impress me over the 35 years I've worked there is how much effort and energy Boeing puts into engineering. And the analysis that the Boeing company undertakes is just, there's a lot of it. We take it all very, very seriously, and everyone is constantly looking out for everyone else.
Just to finish, how do you see the future of computing at Boeing evolving, and also the future of computing perhaps on a broader scale?
Right. Computing is only going to continue to grow. I don't know that it's going to continue to grow at the rate that it has grown over the last couple of years, but computing is only going to increase in importance relative to everything else. There are engineering results that can only be obtained by testing. There are details that can only be understood by running software and doing calculations, and it's just going to continue to grow in importance.
Thomas, thank you so much for joining us. It's great to talk with you.
Thank you. Anytime.